All right, in this lesson we're going to talk about similarity transformations, and which are often called by some other names like a dilation. And simply a dilation is simply a transformation that either enlarges or reduces the original figure proportionally. Since a dilation produces a similar figure, a dilation is a type of similarity transformation. Also, it's important to note that dilations are performed with respect to a fixed point called the center of dilation. So that can, as a, if you, what that would look like is if you have a house, okay, you have a house, and you go to from this point, this center of dilation here, and you draw lines from that point all the way out. um, you would end up having having bigger having a bigger an enlargement. Okay, so anyway, the scale factor of a dilation describes the extent of the dilation. The scale factor is simply the ratio of the length on the dilated image to the corresponding length on the original image, and the letter K usually represents the scale factor of the dilation, and the value of K determines whether the dilation is an enlargement or a reduction. Okay, so pause the video and copy this down. You do not need to copy my rough drawing down. Um, that was just sort of me trying to explain what a center of dilation is. So go ahead and copy all this stuff down here. Okay. All right. So a dilation with a scale factor greater than 1 produces an enlargement, or an image that's larger than the original figure. And here you can see what I was trying to show previously on the on that previous page. As far as this is your center of dilation right here. Okay, so this is an enlargement. It has um, your K is bigger than 1. All right, and a dilation with a scale factor between 0 and 1 produces a reduction, or an image that's smaller than the original figure. So, um, and it obviously it's not going to be a negative, but it's going to be between 0 and 1. So it's going to be a fraction. All right, so in this one it says determine whether the dilation from A to B is an enlargement or a reduction. See, I got a typo here. Is it an enlargement or a reduction? Then find the scale factor of the dilation. Once again, another typo. All right. So the easiest thing to do here is just look at it. Well, from A is our original one. B is our dilation. All right. And so pick a straight side, and I'm going to go from here to here. Well, and if I count, I've got 1, 2, 3. So that particular side length is 3. This particular corresponding side length is 1, 2, 3, 4. All right. So this B is bigger than A, so it is an enlargement. So it's an enlargement. Okay. Then it says to find the scale factor. Well, to find the scale factor, remember it says to take the ratio of the length of the dilated image to the corresponding length on the original. So in this case, it would be B to A, which gives us a scale factor of B is 1, 2, 3, 4, 4, 2, 3. So that is our scale factor, and you see that 4 to 3 is a number larger than 1, because 3 over 3 would be 1. So this is indeed an enlargement. All right, so and I did the bottom. We could have done this side, or we could, if we really wanted to make things difficult, we could have done the hypotenuse. So if we just, I mean, if we look at it, this is 1, 2, 3, 4, 5, 6. So that would be A is 6. This is 1, 2, 3, 4, 5, 6, 7, 8. 8 over 6, which reduces down to 4 over 3 if we simplify it. Okay, so we would expect it needs to be exactly the same. All right, the ratio is going to be the same. All right. Once again, the same thing goes with here. We're going from A right here to B. That's obviously an enlargement. Okay. The value the and so remember we do B over A. All right. A is 1, 2, 3. So A is 3. B is 1, 2, 3, 4, 5, 6, 7. All right. So our scale factor is 7 over 3 or 7/3. All right. Which is more than twice as much. 6/3 would be, which is equal to 2. That would be twice as much. All right. Here, it says what determine whether the dilation from A to B is an enlargement or a reduction. Okay, then find the scale factor of the dilation. Well, you notice that from A to B is going to be a reduction. Okay, because it goes from a big one down to a small one. All right, and we can do this in several different ways. We can use the um, the distance formula to figure out the distance from from A to B, or from here of this side. We can and then go from here to here. Okay, but all parts of the shapes are going to be proportional. So we can just very easily just say, well, what's the ratio from here across the middle of it? Okay, so remember B to A. All right, so that would be 1, 2, 3, 4 is A, and B is 2, which reduces down to having a scale factor of 1/2. All right, that is the that is it for this particular lesson. If you have any questions, make sure that you ask me, um, and we'll talk to you all later.